students. So here's some feedback for our quiz that we took. Notice it says, in the image and table below, data for a newly studied star, Excalibur, and some of the planets surrounding it are displayed. The planets follow nearly circular paths around the central star. So we can see here that there's 4 planets, A, B, C, and D. And we have some information from our picture to see that A and B are relatively close, C is slightly farther away, and D is the farthest planet away. We also can see that A has a fairly small planet, B is a little bit larger, C is even larger, and D is the largest of these. We have some data, and we can see that the data back that up. Planet A, we see the distance, and B, it's pretty much the same distance. But A has a smaller mass than B. Planet C, we have here a slightly larger mass, 2 times 10 to the 23rd, and we see that it is 4 times the distance from the star that planet A and B was. And then for planet D, it's the same mass, so it's just a less dense planet, even though it's a little bit larger, but it's much, much farther away. So we have this data, and we want to know which planet is exerting the greatest force on the star. So I can do 2 things here. First, I can use my understanding of Newton's universal law of gravitation to explain which one has the greatest force on the star. Because we know the star is the biggest, they're all orbiting the star, but that reason is because of the star having the greatest mass. Now, when we look at this, we can see that we could solve, or we could just look at the data and the picture. Either of those ways are fine as long as we are making our claim and supporting it with evidence and reasoning. So here we see planet A is Galahad, and that one has a smaller mass and the same distance as planet B. Planet B has a larger mass and the same distance. So thinking about what we know, when 2 objects are really close together in their distance, they have a greater force of gravity. When they're farther apart, they have less force of gravity. So that distance really is going to already rule out planet C and planet D. We know it's not C or D because those are so much farther away, and their masses really aren't just that much larger. And mass tells us that the greater the mass, the greater the gravitational pull, the less mass, the less gravitational pull. That's why they're all orbiting the star, because it has the biggest mass. But that also is going to help us find our answer here. So planet A has a smaller mass than planet B, but they're the same distance. Bigger mass, same distance, we've increased the mass, and so we know that planet B should have the greatest force on the star. But let's back that up with some calculations. So what I did was I plugged in here to Desmos my calculation. G is the gravitational constant. That's my first number here. This is the mass, 1 times 10 to the 22nd power. This is the mass of planet A. This is the mass of the star divided by the distance square. And I get 2.668 times 10 to the 14th power. Now when I take that same formula, but I change it to the mass of planet B, 5 times 10 to the 22nd, see here, I get 1.334 times 10 to the 15th power. Now notice, 1.3 is smaller than 2.6, but the first answer we got was 10 to the 14th power. The second answer we got was 10 to the 15th power. Now, you could have also solved and seen that the next one is 10 to the 14th, smaller, and the last one is 10 to the 13th, so even smaller. So we didn't really need to solve for C and D, but you can see those calculations here for C and here for D, because we have here how we can find and prove that planet B has the strongest pull. That exponent is the strongest. This is a 1, and then 3, 3, 4, and then another 12 zeros after that. So huge force of gravity here between this planet and the star. That's planet B, Morgana. And so you should have chosen planet B. then our evidence is going to be our numbers. Now, you could just use the mass and the distance and compare it and explain how it's different than the others. You could talk about the picture here, but you should give me some numbers. If you calculated, think about your calculations, think about the numbers you reported, because some people, your work was correct, but your calculation number that you gave me was incorrect. So that's one of the things that people notice. And then in the reasoning, you should be explaining in detail, how does mass affect gravity? How does distance affect gravity? What do we know about those things? All of that together with Newton's law of gravitation. Thanks for watching.